In our last set of videos, we spent quite a bit of time learning how to solve quadratic equations. In these next few videos, we're going to look at quadratic functions and graphs. And remember that an equation is something like this, where it's equal to some number, where all you have are numbers and variables. The same variable, x or t or w or whatever the variable is. And the only thing I can do to that is solve it, which means find the value or values of x that if I plug in, I get a true statement. What we're going to look at in this section are functions. F of x equals ax squared plus bx plus c. Or y equals ax squared plus bx plus c. And we're going to see that we can have infinitely many different values of x and y that if I plug in, make this a true statement. So this is a function rather than an equation. And there's a lot of different things I can do with functions. I can find function values, I can draw graphs, I can use them for models, I can find vertexes or x and y intercepts. I can do a lot of different things with this. Remember when we looked at our basic functions, our basic quadratic function, y equals x squared. That's where b and c were both equal to 0. And we saw that our graph was a parabola. I had 0, 0, I had 1, 1, and I had negative 1, negative 1. And if I found infinitely many values, if I plugged in infinitely many different x's and figured out what y was and then plotted all of those ordered pairs, I would end up with a nice parabolic shape. And we're going to see that any quadratic function, when I graph it, will be a parabola, either facing upwards or facing downwards. So let's actually graph a quadratic using transformations that we learned in an earlier method. So let's say we're going to graph f of x equals, and remember I can use f of x or y. They're the same thing. And let's say that we're going to graph, and go ahead and leave a space here in front of this, and we're going to see why in just a second. So let's say I'm graphing x minus 3 squared plus 4. So I want you to use your basic y equals x squared graph. Think about what your transformations are going to be, and then draw this function f of x using transformations. So pause the video, list your transformations, draw your new graph, and then turn the video back on. All right, so we see that we have a minus 3 here inside the function, so that is going to be right 3 units. And we have a plus 4, that is going to take me up 4 units because that's outside the function, outside the square. So when I draw my graph, I start with my basic graph. Here, through 0, 0, 1, 1, and negative 1, negative 1, but I move it 3 units to the right and 4 units upwards. So my 0, 0 moved here, and then I have 1 over and 1 up, and 1 back and 1 up. And I know the basic shape is that nice parabolic shape, so I can draw my parabola. And this is my graph of f of x equals x minus 3 squared plus 4. Now let's look at some things about this graph. Notice on my original graph right here, y equals x squared, that graph is completely symmetric around this line right here. And the equation of that line, because it's a vertical line, the equation of that line is x equals 0. And because the graph is symmetric around that line, and this is actually a dash line. I'm making it a dash line because it's not actually part of my graph. Put my axis back on here. And then I'm going to draw this line as a dashed line. And it's called an axis of symmetry. Because that's the line that the parabola is symmetric around. I want you to look at f of x, this graph that we just drew here, down here, and I want you to figure out what the axis of symmetry of that line would be. And draw it with a dashed line, and then write the equation of that line. And remember, the equation has to have an x or a y or both in it to be an equation of a line. So see if you can do that. And I see that my axis of symmetry moved to the right 3 units, right along with the entire graph. I went from x equals 0 over here to x equals 3. So my equation is x equals 3. And that is my axis of symmetry. All right, something else that we can notice about this graph is notice that both of these graphs are opening upwards. They're opening upwards. Let's think about what would happen if I were to put a number here in front of this. That 2 means that I'm going to the right 3 and up 4, but I also have a stretch by a factor of 2. So that means that instead of going over to the right 1 and up 1, I would go over to the right 1 and up 2 units, and to the left and up 2 units. And I would have a graph that looks like that. Notice that my axis of symmetry has not changed here. Also, notice that this special point right here, this special point at the very bottom where it curves down and then starts curving back up, has not changed. That point is called the vertex of the parabola. On my basic graph up here, my vertex is the origin, 0, 0. You write the vertex of both of these parabolas. And I see that my vertex is right here, and that is the ordered pair 3, 4. Notice I moved to the right 3 units, and I moved up 4 units to the point 3, 4. Now let's look at one more graph on this same one here. What if I put a negative out front? Remember what the negative does? It reflects that. It's a reflection over the x-axis. So if I had done that reflection before I did my transformation, if I had reflected it downward, then shifted it right 3 units, then shifted it up 4 units, then did my stretch by 2, I'm going to end up with a parabola that looks like this, going downwards, and that needs to be where my vertex is. There we go. So doing that reflection, putting that negative on there, did not change my vertex. It's still the vertex 3, 4. I still was going to the right 3 units and up 4 units. But notice that now, because of this negative, the parabola is opening down instead of up. So let's see if we can figure out our pattern here. Think about looking at numbers. If we have a function, let's say I gave you the function g of x equals I want you to find out 2 things for me. I don't want you to graph this. We're not going to graph it. But I want you to think about what we did in the previous example. And I want you to tell me whether this opens up or down. And I want you to tell me what the vertex is. Just by looking at the function, not graphing it. Kind of think about what your transformations would be. Pause the video. Write whether it's up or down, and write what the vertex is. All right. To know whether it opens up or down, we look at the sign out here. This is minus, so that means that this opens down. Opens down. The vertex, we're going to be going left 7 units and down 11 units. So that means the vertex is going to be -7, -11. Notice on this one, we had a +7 here, so that meant we had a -7 for our x-coordinate of our vertex. On this one, we had a -3, so that meant we had a +3 as the x-coordinate of our vertex. If I were to write this as a formula, f of x equals a times x minus h squared plus k. We're going to see that we can use the numbers here, the h and the k and the a, to find out information. And as we saw in our previous examples, when the number out front here, the a, was negative, it opened downwards, and when the a was positive, it opened upwards. So if a is greater than 0, the parabola opens up. Go ahead and leave some space here because we're going to come back and put several more pieces of information. If a is less than 0, it opens down. Let's talk about the vertex. I want you to see if you can write what the vertex would be if we have the function f of x equals a times x minus h squared plus k. I want you to use letters in this function to write what the vertex would be. And notice we have the h here. That's my shift left to right. And we have the k. That's my shift up or down. So my vertex is HK. What about the axis of symmetry? We know it's going to be a vertical line, x equals something, a vertical line. If we look here, we see that that axis of symmetry is always going to go right through the vertex. So it's going to be the vertical line through the x coordinate of the vertex, which is h. So our axis of symmetry is x equals h. Let's see if we can use that information to find, given a function, I want you to write whether it opens up or down. And I want you to write the vertex based on what we just learned. And we have a negative here, so it opens down. And my vertex, I have a +2, that's x minus -2. It's going to shift to the left 2, so it's -2, +5. Also, I want you to write your axis of symmetry. Go ahead and do that. And it's always a vertical line, x equals. Don't forget to put the x equals. And it's the x-coordinate of the vertex. We're going to be interested in some other things about these parabolas. So let's go ahead and draw a quick sketch of our parabola here. Go ahead, plot the vertex, and then just draw the parabola. Don't worry about plotting a bunch of points. Just plot the vertex and then open it the correct way and go ahead and sketch your axis of symmetry. All right, our vertex is -2, 5. And it opens downwards. So I'm just going to sketch this. I don't really know where it crosses the x and the y-axis. We'll look at that some more later. What we're interested in here is the axis of symmetry and the vertex. All right, now notice when my parabola opens downwards. Notice that the very highest point on the parabola is the vertex. And remember that these are values of y. These are my f of x's. This is my x. So the highest possible value that the function takes on is 5. And it is a high point, so it is a maximum. So here I have a maximum, and the maximum is the number 5. And notice the 5 is the y-coordinate of the parabola. Let's go back to this one. I want you to look at your picture and write the domain and the range. And remember domain, you're sweeping across from left to right. Where am I touching the graph if I draw a vertical line? In the domain, you're sweeping upwards. Where am I touching the graph? Going left to right. So pause the video, write the domain and the range looking at the picture. And we see that our domain, going left to right, we're always touching the graph, so it's -infinity to infinity. And my range going top to bottom, or excuse me, bottom to top, I'm going forever downwards. As I keep coming up, the last place that I'm touching the graph is at 5, and I am including 5. So that's my range. Let's look back and see if we can see a pattern here with the h and the k. Notice here where I'm opening downward, I'm always drawing a graph that looks like that. I'm always going to have a maximum and that maximum is always going to be the y-coordinate of the vertex. My domain is always going to be all real numbers, negative infinity to infinity. But let's think about what our range is going to be. It's going to be coming up from negative infinity to that highest point, that value k, and we're going to include k. I want you to see if you can do the same thing for the case where a is greater than 0. Do we have a maximum or do we have a minimum? What is the value of that minimum? And then what would my range be? See if you can write those two statements here and here. Okay, we see when we open upwards that we're going to have a low point, a minimum. And that minimum is going to be the y-coordinate of the vertex, which is k. And we're going to see our range sweeping up from bottom to top. We're starting at k, including k, and going to infinity. So we can get a lot of information about a graph if it is in this special form, and this is called perfect square form. So I'm going to give you one more example. J of x equals I want you to write the vertex. I want you to write if it opens up or down. I want you to write the axis of symmetry. I want you to write the range. I want you to write whether you have a maximum or a minimum and what that maximum or minimum value is. And if it helps you to draw a graph of it, a quick sketch to see how this looks, you can go ahead and do that as well. So pause the video, find all of this information, and then turn the video back on. Okay, I do like to draw my graph. I find it helps me. So my vertex is going to be 3, -8. Because the 5 is positive, it opens up. So I can go ahead and plot that. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. Plot that point, and it opens upwards. And again, we're going to look at the x and the y intercepts over here in a later video. So for now, just draw a quick sketch. And we see that our axis of symmetry runs right through the middle of this parabola and is the equation x equals 3. My range comes from down here upwards, so my range is -8 to infinity. And I can see by the picture I do have a minimum value, and the minimum is this value of y here, -8. In our next video, we're going to see what do we do if we can find all this same information, all of this same information here, but what if the original equation is not written in perfect square form? How can we find all of